Hello everyone, my name is Wellington bunyau Anna Joseph and I'm from class DKM4B session. Today, I would like to share to all of you about the meaning of engineering mechanic and engineering mechanic. First, engineering is the branch of science and technology concerned with the design, building, use of engine, machine and structure. Second, mechanic is the branch of applied mathematics dealing with motion and force producing motion. And the last one, engineering mechanic is involved the application of the principle of mechanics to solve real-time engineering problems. There are two types of engineering mechanics such as static and dynamic. Static is the branch of mechanics that deal with the study of objects at rest. Objects at rest may or may not be under of influence of force. Dynamic is the branch of mechanics that deal with the study of object in motion and the force causing such motion.
Gentlemen, today I want to talk about the fundamental of engineering mechanics. There are 6 types of fundamental of engineering mechanics, which is space, time, mass, force, particle, and rigid body. So the first one is space. Space is a geometric region in which events involving bodies occur. The concept of length is needed to locate the position of a point in space and thereby to describe the size of physical system. The standard unit of length measurement is meter. So the second one is time. Time is a concept of measuring the successions and the duration of events, or a concept of ordering the flow of events. For an accurate description of when has happened an event, we must find an action which appears to be completely repeatable. The third one is mass. Mass is a measure of the amount of material in a body. The body is constant regardless of its location. The standard unit of mass measurement is kilogram. So the fourth one is force. Force represents the action of one body on another. It can be exerted by actual contact or at a distance, as in the case of gravitational forces and magnetic forces. A force is characterized by its point of its 3 applications: its magnitude and its direction. A force is represented by a vector. The fifth one is particle. Particle is an entity that has a mass, but size can be neglected. A body whose size or a system whose internal structure is not completely relevant to the properties described by the observer. In the other words, the body may be modeled as a point of concentrated mass, and the rotational motion of the body can be ignored. So the last one is rigid body. Rigid body is a combination of large number of particles occupying fixed position with respect to each other. A body that does not deform under the action of force. Generally, the size of a rigid body influences its response to force. So thank you. That's it about the fundamental of engineering mechanics. Thank you.
Hai, pada hari ini saya ingin mengajar anda bagaimana wujudnya Newton's Laws of Motion. Newton's Laws of Motion berasal daripada nama, iaitu Isaac Newton 1642-1727 yang dikenali sebagai bapa kajian dinamik dan kajian gerakan. Beliau membangunkan 3 undang-undang iaitu first law, second law and third law yang menjadi asas mekanik klasik. Mereka dipercayai benar kerana keputusan ujian yang dibuat oleh saintis tersebut bersetuju dengan undang-undang yang dihasilkannya. Mari kita tengok first law. First law. Sekiranya badan sedang beristirahat, ia tetap berehat, atau jika ia bergerak dengan hala laju seragam sehingga ia bertindak oleh kekuatan bersih. Hala laju seragam bermaksud objek bergerak pada kelajuan malar tanpa mengubah arah, iaitu garis lurus. Kekuatan bersih pula bermaksud daya yang bertindak pada objek tidak seimbang. Dengan kata lain, undang-undang pertama menyatakan dua perkara. Objek pegun hanya akan bergerak jika terdapat daya tak seimbang yang bertindak di atasnya. Objek bergerak hanya akan mengubah kelajuan atau arah jika terdapat daya tak seimbang yang bertindak di atasnya. Bahagian pertama menyatakan bahawa jadual yang terletak di atas tanah tidak akan bergerak kecuali ditolak. Walaupun graviti bertindak di atas meja, bertindak di atas meja, menariknya ke bawah, ada daya reaksi dari tanah yang menolaknya. Daya yang menolaknya bertindak di atas meja seimbang, jadi objek tidak akan bergerak. Bahagian kedua lebih sukar difahami. Bola yang bergerak di sepanjang permukaan yang rata akan melambatkan dan akhirnya berhenti, tetapi ini kerana geseran yang merupakan daya yang melambatkan bola ke bawah. Bola yang meluncur ke bawah cerun juga dipengaruhi oleh geseran, tetapi daya graviti yang menyebabkan ia bergerak lebih kuat. Di tempat tanpa dipengaruhi oleh geseran, tetapi daya graviti yang menyebabkan ia bergerak lebih kuat. Di tempat tanpa daya geseran, rintangan udara dan graviti, objek bergerak akan tetap bergerak dalam garis lurus jika tidak ada daya untuk melambatkan atau mengubah arahnya. Seterusnya kita ke Newton's second law. Newton's second law, undang-undang gerakan Newton kedua berkaitan dengan tingkah laku objek yang mana semua daya sedia ada tidak seimbang. Undang-undang kedua menyatakan bahawa pecutan objek bergantung kepada dua pemboleh ubah, daya bersih yang bertindak ke atas objek dan jisim objek. Newton's second law mempunyai definisi yang tersendiri, iaitu mempunyai rumus-rumus untuk mengira pergerakan, movement, daya, hala laju, berat, dan lain-lain lagi. Newton seterusnya adalah third Newton's law. Ini lebih difahami dengan bola biliar, di mana anda boleh melihat pasangan tindakan atau tindak balas dengan mudah. Begitu juga apabila anda menendang bola sepak. Bukan sahaja bola bergerak, tetapi anda merasakan daya di kaki anda. Saiz daya pada objek pertama sama dengan saiz daya pada objek kedua. Arah daya pada objek pertama bertentangan dengan arah daya pada objek kedua. Angkatan sentiasa datang secara berpasangan. Pasangan kuasa tidak balas tindakan yang sama dan bertentangan. Pelbagai pasangan kuasa tindak balas bertindak jelas dalam alam semula jadi. Pertimbangkan dorongan ikan melalui air. Ikan menggunakan siripnya untuk menolak air ke belakang, tetapi dorongan pada air hanya akan berfungsi untuk memcepatkan air. Oleh kerana daya terhasil daripada interaksi bersama air juga harus menolak ikan ke depan, mendorong ikan melalui air. Saiz daya pada air sama dengan saiz daya pada ikan. Arah daya di atas air ke belakang adalah bertentangan dengan arahan daya pada ikan. Untuk setiap tindakan terdapat tindak balas yang sama dan bertentangan. Pasangan tindak balas bertindak balas memungkinkan ikan itu untuk berenang. Pertimbangkan gerakan kereta dalam perjalanan ke sekolah. Sebuah kereta mempunyai roda yang berputar ke hadapan. Apabila roda berputar ke hadapan, mereka mengenggam jalan dan menolak jalan ke belakang. Oleh sebab daya terhasil dari interaksi bersama, jalan itu juga harus menolak roda ke depan. Saiz daya di jalan sama dengan saiz daya pada roda. Arah daya di jalan raya adalah bertentangan dengan arah kuasa pada roda. Untuk setiap tindakan depan, saiz daya di jalan sama dengan saiz daya. Untuk setiap tindakan terdapat tindak balas yang sama dan bertentangan. Pasangan daya reaksi bertindak membolehkan kereta bergerak di sepanjang pembukaan jalan. Okey. Seterusnya kita melihat gambar. Sekian itu saja daripada saya. Terima kasih.
Assalamualaikum dan salam sejahtera kepada semua student. Saya akan menyambung bagi topik yang telah disampaikan oleh kawan saya tadi, iaitu basic quantities of engineering mechanics. So, bagi introduction, mechanics is physically of science concerned with the behavior of bodies that are acted upon by forces. For example, static is study which deal with the condition of body equilibrium subjected to external force. In other words, when the force system acting on a body balance the system has no external effect on the body. The body is in equilibrium. Second is dynamic. It's also a branch of mechanics in which the force and the effects on the bodies in motion are studied. Dynamics is subdivided into two parts, that is kinematic and kinetic. First, kinetic deals with the geometry of motion of bodies without an application of external force. Kinetic deals with the motion of bodies with application of external forces. So, other than that, they have hydromechanic. Hydromechanic is the study which deal with condition of fluid under which it can remain at rest or in motion. Hydromechanic can be divided into hydrostatic, hydrodynamic. Okay, other than introduction, I give the basic term used in mechanics. So there are 6 of them. The following are basic terms which are used in mechanics. For example, mass, length, time, space, displacement, velocity, acceleration, and momentum. Sorry, it has 8 of basic terms in mechanics that used in mechanics. So mass, we all know that mass is like when it possessed by a body, it called mass. The mass a body cannot change unless the body is damaged, and part of it has physical separated. Okay, so next is length. Length, we do measure a linear for distance, like for example from here to here. Okay, other than that is time. Time is measure succession of event. The successive event selected is rotation of Earth about its axis, and this is called a day. Next is space. Any geometric region in the study of a body has been done is called space. Other than space is the displacement. It is defined as a distance moved by body or particle in specified direction. Next is velocity, the rate of change displacement with respect to time, defined as a velocity. For example, time defined as a velocity. Next is acceleration. We know as acceleration is called speed, but this is it is rate change velocity with respect to time. Next is momentum. So the momentum we know as momentum is equal to mass times over velocity. So the product by mass and velocity is called momentum. Okay. Now next is we going through to laws of mechanics. Laws of mechanics, it has 6 fundamental laws of mechanics. That is, first is Newton first law, second is Newton second law, third is Newton third law, fourth is Newton laws of gravitation, the fifth is law of transmissibility of force, the last one is parallelogram law of forces. Okay, so I want to explain about the Newton first law. The Newton first law is that on every body continues in state of rest or of uniform motion in straight line unless it is compelled by an external agency acting on it. Okay, now is a Newton second law. In a state that the rate of change of momentum, a body is directly proportional to the impressed the force, and it takes a place in the direction of the force acting on it. According to this law, force is equal to rate of change of momentum, but momentum is equal to mass over velocity. As the mass do not change, force is equal to mass times rate of change of velocity. Force, in example, force is equal to mass times acceleration. F is equal to m times a. So the third one is Newton third law. It is stated that for every action there is an equal and opposite reaction. So the last one is might be a unit and dimension of quantities. For the unit, you guys all know that the unit is to be like in weight, current, speed, or different units are used. So like meter, kilogram, or centimeter, any of people use in measuring or calculating something in engineering mechanics. Okay, so it also includes SI unit, International System of Units. So I explain about the SI unit. The fundamental units of the system are meter, that I said before, for the length, and the kilogram, kg, the unit, SI unit for the mass, and the second is S for time. The unit force is Newton. The 1 Newton is the amount of force required to induce acceleration of 1 minute per second square on 1 kilogram mass. So the dimension, the branch of mathematics dealing with the dimension of quantities is called dimension analysis. There are 2 types of system of dimension analysis, which absolute system and gravitational system. Okay, for the quantities dimension of quantities MLT and FLT, you guys can see over here. You guys can see over here. They have length, mass, second, and area, volume, velocity, acceleration, momentum, weight, force, power, and density. Okay, so you guys can find it on Google or you can ask with your lecturer or teacher to get the information from them to know more. Okay, so next will be scala and vector. We proceed by aqid azrid. So thank you.
Assalamualaikum dan salam sejahtera. My name is Aqid Azrid bin Abdul Latif. Today I want to discuss about scala and vector. Okay, for the scala, meanings is any physical quantity that does not include direction in the known as a scalar quantity. Okay, for the vector, meanings of vector is vector quantity is one that has a both magnitude and a direction. Okay, for the example of a scala is like a mass, length, time, temperature, and density. Okay, for the vector is example for vector is velocity, force, displacement, and momentum. This is for the example vector and scala. Okay, for the quantities, scala is one-dimensionally quantities. For the quantities of vector is multi-dimensionally quantities. Okay. For the change of scala is it changes with that change in the depth magnitude. For the vector change is it change with that change in the their direction or magnitude or both. Okay, itu saja dari kami untuk grup kami video, dan sekian, terima kasih. Enjoy this video.